Hey everyone, and welcome. Today, we're going to talk about a piece of tech that, well, it pretty much runs a huge chunk of the modern internet, even if you've never heard of it. I'm talking about MongoDB. And it's a database that was built specifically for, you could say, the beautiful mess that is modern data.
All right, so let's just jump right in. To really get why something like MongoDB even had to be invented, we have to ask a really basic question, right? Why wasn't what we already had good enough? What happened? Why did the internet, as it got bigger and bigger, suddenly need a totally new way to think about storing information?
Well, the whole answer really comes down to a big conflict. See, for decades, the entire digital world ran on what we call SQL databases. The easiest way to think about them, imagine a super strict, perfectly organized spreadsheet. Every single row has to have the exact same columns, no exceptions. But the internet is not a neat spreadsheet, is it? It's messy, it's chaotic, it's always changing, it's a beast. And that chaos created the need for a whole new way of doing things, often called NoSQL. And this new way is much more like a flexible filing cabinet, where every folder inside can be totally different.
So let's start there. Let's take a look at that old world, the world of rigid tables, and figure out exactly why its rules started to bend, and then why they eventually just broke.
And you know what? For a long time, this system was absolutely perfect. I mean, think about it. If you're a bank, every single customer account has the same basic info, right? Account number, name, balance. And these relational databases, things like MySQL, they were geniuses at managing this kind of predictable, structured data. Everything had its place, a predefined slot, and it was super efficient.
But then, the internet happened. It just exploded. And with that explosion came this absolute tidal wave of data. And this data was anything but neat and predictable. No, it was complicated, it was messy, and it was coming in at a scale that nobody had ever seen before.
People who study this stuff often talk about the 3 V's of big data. First, you've got volume. We're talking just an enormous, staggering amount of information. Then there's velocity. The data wasn't just big, it was arriving at an incredible speed, streaming in constantly from users and sensors. But the real killer, the one that really broke the old model, that was variety. Suddenly you had user profiles and blog posts and photos and comments and server logs, all these different shapes and sizes of data. And trying to cram all of that into one rigid spreadsheet, it was becoming an absolute nightmare. And this, right here, is where MongoDB comes into the picture. It was literally designed from the ground up to deal with this chaos. And it did that by completely rethinking the most basic idea of what a database even is. It was time to start thinking outside the spreadsheet.
So here's the fundamental shift, the big idea. Forget rows and columns, just throw that idea out. Instead, MongoDB stores data in what it calls documents. And I know that sounds like a simple word change, but trust me, that one little shift in terminology represents a massive change in philosophy. Okay, to get our heads around this, let's go back to that filing cabinet analogy. In the MongoDB world, a collection is basically one of the drawers in the cabinet. So you might have a collection called users, or another one called products. It's pretty much the direct replacement for what we used to call a table in the old SQL world. Okay, so you've got your drawer, your collection. Now, what's inside it? Well, inside that drawer, you have your documents. And each document is like a single folder that has all the info about one specific thing. One user, one product, you name it. This is the new equivalent of a row from the old spreadsheet world. And this is where the magic really happens. See, a document stores its data in these really simple field value pairs, kind of like a contact card in your phone. Name, Alice. Email, alice@example.com. But, and this is the game changer, a document can hold other data inside of it. So, for instance, a user's document could have a whole list of their past addresses just sitting right there inside that one document. Now, in the old SQL world, you'd have to link multiple spreadsheets together to do that, a complicated process called a join. But here, it's all self-contained in one spot, which, as you can imagine, makes getting that data back way faster. So this whole document model, it isn't just a different way to organize stuff. No, it actually unlocks some serious superpowers, especially for the kinds of apps we all use today, the ones built to run in the cloud. This is the point where all that flexibility we've been talking about turns into a real competitive weapon.
All right, pay attention here because this next part is the single most important idea you need to understand about MongoDB. It's a concept called a flexible schema. Now, the fancy technical term is polymorphism, which literally just means many forms. And believe me, it is the key to everything. And here's what that flexibility looks like in the real world. Imagine we're looking inside that same user's collection, our filing cabinet drawer. Look at what's inside. Document 1 is for Alice, and it might just have her name and her email. Simple enough. But document 2 is for Bob, and it has his name, his phone number, and a whole history of his past addresses. They're both user documents. They're in the same collection, but they don't have to have the same fields. They can be different. That is polymorphism. That's the big deal. So what's the big deal? Why does this matter so much? Well, it means that developers can add a new feature, say they decide to start collecting phone numbers, without having to shut everything down and rebuild the entire database structure. They just start adding the new phone number field to new users. It gives them this incredible speed and agility to let an application grow and change over time. Okay, let's talk about its first big superpower. This one is all about how it handles just massive, massive growth. It's a feature called sharding. And all that really means is it has the ability to chop up your data into pieces and spread it out across a whole bunch of different servers. And the real-world benefit of this? Oh, it's huge. Think about it. Instead of having to buy one single gigantic, ridiculously expensive supercomputer to run your growing database, that's called scaling vertically, you can just keep adding more cheap, off-the-shelf computers as you need them. This is called scaling horizontally, and it is a fundamental principle of how the modern cloud works. Superpower number 2 is all about making sure things never, ever break. It's called replica sets, and it's pretty clever. The system automatically keeps multiple identical copies of all your data running on different computers. So if one of those computers suddenly fails, poof, it goes offline, one of the copies instantly takes over, and nobody even notices. To the user, it looks like nothing ever went wrong. That's called high availability, and it's built right into the system. So when you combine these superpowers, flexibility, massive scalability, and rock-solid reliability, where do you actually see MongoDB being used out in the real world? Well, the short answer is pretty much everywhere. E-commerce sites, for example, they love it for managing their products catalogs. Because think about it, a t-shirt has different details than a laptop, right? The Internet of Things, or IoT, uses it to handle that constant flood of data coming in from millions of different sensors. Content management systems, the things that run blogs and news sites, use it to store all kinds of different content, articles, videos, user comments, and real-time analytics platforms use it to track what you're doing on a website right now to give you a personalized experience. So let's just quickly recap the key takeaways here. Why would you choose MongoDB? Number 1, it's fast, really fast, because reading one single document is almost always faster than trying to piece together information from multiple spreadsheets. Number 2, it gives developers incredible flexibility, so they can build and change things quickly. And number 3, it's designed to scale in a really cost-effective way, one that's just perfectly built for the cloud. So, if there's one thing to remember, it's this. MongoDB isn't automatically better than those old SQL databases. It's just different. It was purpose-built for a new kind of world, a world where data is messy and varied, where it arrives at a massive scale, and where the apps we use need to change and evolve constantly. Simply put, it was designed for the modern cloud-native world. And that kind of leaves us with a final, lingering question to think about. We've seen how we traded rigid structure for incredible flexibility. But as our data gets even messier and even more unpredictable, I'm talking about data from AI, from virtual reality, from things we haven't even invented yet, is that trade-off always going to be the right one? Will flexibility always beat structure, or is there a point where too much flexibility just becomes a new kind of chaos? It's something to think about.